Hello everyone and welcome to this video. Welcome to our tutorial on customer segmentation analysis using Pandas. Today we'll explore how to understand customer behaviors by analyzing their purchasing patterns over time. Our ultimate goal is to segment customers into distinct groups, allowing for more personalized and effective marketing efforts. Let's dive into the scenario. Your boss has observed that the company's marketing campaigns aren't hitting the mark. To improve this, the marketing team wants to understand various customer behaviors and segment them into groups like loyal customers, one-time buyers, and seasonal shoppers. This segmentation will help tailor marketing strategies to each group. We've got a data set with the purchase history of 5 customers over time, and our task is to perform customer segmentation using K-Means Clustering. Step 1 is to load our data set. We'll begin by loading the data and taking a quick look at the first few rows to get a sense of its structure. Let me show you how you can do this using Pandas. First, we import Pandas as PD. Then we load our dataset using pd.read_csv and pass in the file name dataset.csv. Finally, we use the head method to display the first few rows of our data. This gives us a quick overview of what our dataset looks like. In our dataset, we have several important columns. Customer ID is a unique identifier for each customer. Purchase frequency tells us how many times a customer has made a purchase. Total amount spent shows the total monetary value spent by the customer. Lastly, last purchase date indicates the most recent date a customer made a purchase. Step 2 is data exploration. Before we dive into clustering, it's crucial to explore the data set to understand the distribution of data. We'll check for any missing values and get a summary of the data set. So let's go ahead and use the data.info method. This will provide us with a concise summary of the data set, including the number of non-null entries and the data type of each column. It's a great way to quickly check for any missing values. Next, we'll use the data.describe method. This gives us a statistical summary of the data set, including measures like mean, standard deviation, and percentiles for numerical columns. It's a helpful way to understand the distribution and central tendencies of our data. Step 3 is data pre-processing. Before we can perform clustering, we need to pre-process our data. This involves handling any missing values, normalizing the data, and converting data information into a numerical format suitable for clustering. So what we are doing here is first converting the last purchase date column to a datetime format using pd.to_datetime. Then we calculate the days since last purchase by subtracting the last purchase date from a fixed date, October 1st, 2023. We drop the original last purchase date column as it's no longer needed. Next, we handle any missing values by filling them with the mean of the respective columns using data.fillNow. Finally, we use the head method to check the first few rows of our preprocessed data. Step 4 is data normalization. To ensure that each feature contributes equally to the distance calculations in K-means, we need to normalize our data. Let me show you how you can do this using scikit-learn. First, we import standard scalar from sklearn.preprocessing. We create an instance of standard scalar and fit it to our data using the fit_transform method. This scales our data so that each feature has a mean of 0 and a standard deviation of 1. We then display the first 5 rows of our scaled data to verify the transformation. Step 5 is K-means clustering. Now that our data is pre-processed and normalized, we can apply K-means clustering to segment our customers. We'll begin by determining the optimal number of clusters using the elbow method. So let's go ahead and import K-means from sklearn.cluster and matplotlib.pyplot. As PLT, we initialize an empty list called inertia to store the inertia values for different numbers of clusters. We then loop over a range from 1 to 10, creating a K-means instance with n underscore clusters set to the current number and a random state of 42 for reproducibility. We fit the K-means model to our scaled data and append the inertia value to our list. Finally, we plot the inertia values against the number of clusters using matplotlib to visualize the elbow method. Let's talk about finding the elbow point. Inertia decreases sharply as the number of clusters increases. The elbow is where this decrease slows down, forming a bend. The optimal number of clusters is at the elbow, where adding more clusters barely reduces inertia. In our plot, 3 or 4 clusters seem optimal. We stop at the elbow because before it, more clusters significantly reduce inertia. But after it, we face diminishing returns and the risk of overfitting. Therefore, 3 or 4 clusters are the best choice for segmentation. Step 6 is applying K-means. Based on the elbow method, we should choose 4 as the number of clusters and apply K-means to segment our customers. So what we are doing here is creating a K-means instance with n underscore clusters set to 4 and a random state of 42. We then fit the model to our scaled data and predict the cluster for each data point using fit underscore predict. The resulting cluster labels are added to our original data as a new column called cluster. Finally, we use the head method to display the first few rows of our data with the new cluster assignments. Step 7 is visualizing the clusters. To better understand the customer segments, we'll visualize the clusters using a scatter plot. First, let's convert the cluster column to a string format. So let's go ahead and convert the cluster column to a string type using the asType method. This is important for visualization purposes. We then use the head method to check the first few rows of our data with the updated cluster column. Now let's use Plotly to visualize our customer segments. Let me show you how you can do this using Plotly. First, we import plotly.express as px. We create a scatter plot using px.scatter, passing in our data, specifying purchase frequency for the x-axis and total amount spent for the y-axis. We color the points by the cluster column and set a title for the plot. We also define labels for the axes and choose a color sequence from Plotly's qualitative color sets. Finally, we display the plot using fig.show. Let's interpret our customer segments. Cluster 0, shown in green, represents one-time buyers. They have low purchase frequency and low spending. The strategy here is to use re-engagement campaigns and discount offers. Cluster 1, in blue, consists of loyal customers with high purchase frequency and high spending. We should focus on loyalty programs and exclusive discounts for them. Cluster 2, in red, includes moderate buyers with medium frequency and moderate spending. Personalized recommendations and limited time offers work well for this group. Finally, Cluster 3, in purple, represents seasonal shoppers who make infrequent purchases but spend a lot. Seasonal promotions and event-based campaigns are ideal for them. In terms of business insights, we should nurture loyal customers with rewards, convert one-time buyers into repeat customers, target seasonal shoppers before peak sales, and encourage moderate buyers with incentives. Thank you so much for watching this video. Don't forget to subscribe my channel and see you next time.